Okay, so um, this lecture is going to slightly differ than Alberto's lecture in the other 309 section, largely because of the fact that a lot of this is based on his prior material from the summer and prior when he's taught these classes before, and on his own code and frameworks that he's built for this. And I'd like to build on those frameworks so that we don't differ too much, so I'm not going to try to do anything crazy. But in his lecture, which I'm happy to post for anyone who would like to look at that one as well, he does go into quite deep depth on the kind of underlying simplex architecture and framework that he's built out for a lot of these examples that we'll be using. So this lecture, I'm going to kind of skip ahead of that, where he goes and he shows how to start from the sandbox example. So sandbox is in the class repository. To really quickly run it, you'll notice here it is. It does a lot of stuff. You'll notice there's models being loaded already. There's movement. There's the ability to, look around. There's this UI stuff that's being provided by IGM GUI. There's a lot of stuff going on that is quite advanced seeming. So, even there's sound in some of these examples. So, in that first lecture, he breaks down how to get to the starting point of what we're going to start off, which is in this lecture, which is CO9. So if I'm going to hit CO9 and run it, you'll notice that this beginning project, it gives us some of these capabilities. We can change orthographic projections. Right now there's nothing in here, so there's not much we want to do. But in that class, in that particular lecture, which I'll post, Alberto goes through breaking down that sandbox example to sort of this standard starting point for projects, which is the CO9 simplex base. So if that's valuable to you, please take a look. I do recommend it. But in this case, I'm going to start off really kind of exploring simplex base, showing some of the things that are different at least, so that you know, because you'll see a lot of these this in the rest of the projects and the rest of the example code. And then we're going to try to build a little mesh class, a kind of a precursor to what comes up next in the next project. So start, as before, we initialize, we have a new application. This is very similar to what we had before. You'll notice there's a couple of changes here. So, whoops, in an older one, we have this new app shaders, we give it a name, and then we run it. Here we have slightly different architecture, which is, right here we have, we new and whatever. Here we initialize it, but then we actually explicitly call an init function. Let's take a look at this init function really quickly. That takes an application name, a size, whether or not it's full screen or borderless is another one that we're using. Looks like we're using this one, right? You can also choose a different constructor here. This app class main is in our thing. You can have different sizes. You can choose the size of your window, whether it's full screen, and provide the application name, and so on. And then we run separately. And you can see that our run function has gotten significantly more sophisticated, where we'll hit run and this will initialize the things we need to initialize, which is a little bit more generalized now. I do recommend you walk through the code and kind of understand what's going on if you'd like. But for the most part, we're running and we pull the event like we were doing before. We have slightly more sophisticated event handling code than we did prior. And we have these functions, process, joystick, released, and these go into the app class controls file, which is up here, which we get a little bit more control over how we handle stuff, right? So you can kind of see there's a lot more stuff to handle, right? Like we can change the camera rotation. There's a concept of a camera. There's a lot of stuff that we haven't really done before. And you can see also here we've got camera position, where if we move forward with a certain speed. If we move backward, and so on and so forth. There's a lot of stuff going on. But in our case, it's actually pretty straightforward what we want to do. So let's open up our app class. This is what our previous code was, and you can sort of see this is where we would set our kind of specific things. So let's see here. We probably want to, I don't know, let's follow the instructions. Let's do this. Done back. IXB big M. And then we don't really need this. Great. Cool. So we're done. And now we would I wouldn't worry too much about what all these things do at the moment, because what we really care about is the display, the rendering, and that's about it. So what we want to do in this particular example is we want to get to a point where we have something like this draw or render or whatever. We want to basically render that triangle. Let's get rid of this for now because we're not going to use it. We're not going to use the mesh manager. Well, it's fine. We'll keep the skybox for now. And we want to get to a point where we have a triangle mesh that is going to render a triangle much like what we had before. So how do we get to that point? Well, the first thing, right, is we need to create a mesh class of some kind. Because in this case, we would say we had this thing, we want to do mp triangle is equal to new my mesh 0.5f, but my mesh isn't anywhere. Well, this is a different project. So, but it's not going to be found in my project. So what do I need to do to get to this point? Okay. Well, first things first, we need to create a new header file. And let's do a new item. And let's make sure we're in the right place. And let's call this mymesh.h. And very quickly, we want to kind of spec this out. mymesh.h, define mymesh.h, and if and what do we need? We'll need some kind of a class. Obviously, let's call it mymesh, right? And then, what else do we need? We need public. We'll need a mymesh constructor of some kind. And we'll also need a destructor. Cool. And that's kind of to start. I guess we'll need a bunch of vertices. So let's include a vector here. And let's not forget our GLM. So if you remember here, we'll need all this stuff. We probably don't need that much, but let's create a vector of GLM vectors, vertices. And then let's create a function init init the shader. Sure, let's do that. Let's init the shader, and let's init the triangle. Right now we're going to create only a triangle, and then we'll have that draw function, like we were talking about, because we need to have a way to do it. And yeah, if we're going to set up the shader stuff here, then we need a GLUint for the mshader program ID. And we'll need the VAO that we'll set up for this particular object, and then we'll also need a VBO, which is going to store our buffer, our data buffer, as we were doing previously. Cool. This is probably enough to get going, but you'll notice that I don't have any code. But at least now, if I go to my app class, I can at least do this. What is that? Let me change this. That's actually a good point. I do want to have a size. So let's not do it that way. I don't want this. Let's change this to MP triangle set scale. Great. Whoops. Whoa. Never seen that happen before. Where's my solution now? Yes, I want to reset the, there we go. Okay, cool. So I want to do that. So I also need my mesh to have some kind of a function set scale floats size. Cool, great. I do need to go to my app class.h and include now my mesh. And if I want to have it like this, I do need to set up a little place for it somewhere. What we could do is we could put it up at the top so we don't get too lost. Here, we can do a my mesh np triangle equals multiplier. However, there's a better way to do this. Let's get rid of it here, and we can create actually a what's called forward declare the class. This is actually a much better way to develop as long as you can, because what I can do now is I can tell my application class, hey, there's a object called myMesh somewhere, but this file doesn't really need to know the implementation at all, and I can include it here. So right now it'll tell me, hey, pointer to incomplete class type is not allowed, because it doesn't know what it means. It doesn't know what functions it has. But as soon as I provide the header the header here, it now knows what functions are available to it. What's nice about this is that class myMesh doesn't require the linking, not linking, but the inclusion of another header file. And you can imagine if you have a really big project with thousands of different files, and if you change one file, they all have to recompile. Following this general pattern will allow you to get to much, much faster compilation times and much better organized projects. This is a really important thing in C++, especially as you get bigger and bigger projects. Like, for example, I've shown you some of my code. Those files, I think we have like 35,000 files. Yeah, a lot of files. Like the Chromium project is, tons and tons of files. It's like 11 million lines of code, and so you do have to be cognizant of just how much stuff is out there, especially header files, which get bloated pretty quickly. Anyways, moving on. So now I have this mesh. If I try to compile this, it'll probably give me a bunch of bugs because set scale is not implemented. A lot of this stuff isn't implemented, so it's going to give me my mesh, like even the constructor isn't implemented. So how do we fix that? Well, let's create a new file, which is going to be called mymesh.cpp. And the first thing we do is we include my mesh. Great. And the easiest thing for us to do immediately is to create the constructor. And so, great. I'm going to add a new function here called init. And I'm actually going to create something unique. And you'll notice this, the reason I'm noting that this is different is because it is different. I'm doing it in a different way than you'll see later in the project, but hopefully you'll learn something slightly new or different than from what I'm doing. And so what I like to do, generally speaking, in my code is I like to have constructors empty. My mesh, right now the destructor is going to be empty as well. And then we'll do our initialization. Let's take all of these. Why is this squiggly lined? GLUint is undefined. What do we have to define? We have to include. What do we have to include for it to be happy? What do we have to include? Definitions. That's fine. Cool. So I'm just going to take these. I'm going to move this down here. And I'm going to take these. Oops. Where's mymesh.cpp? And I'm going to just literally cut and paste it. So the first thing that we get is no complaints. And now we have to fill out these functions. Okay, to initialize, one of the first things we have to do is we have to set up the VAO. So let's start doing that. We'll do gen vertex arrays. We're going to create one, and that's going to be the mVAO. And then we're going to generate a buffer. And that's the UVBO. Now we're going to bind that vertex array, which means now we're using it. Great. And then we're going to bind the array buffer, so GL array buffer, and that's going to be we're going to use the VBO we created. Great. And because we can do this here, but let's split it up. So this is where we would set up the program. So let's just call init shader and do it there. So let's set up everything else. Set up shader, and then here, well, let's put a. But this is let's put a stub here for now. We might not do it this way. We'll see. So now the next thing with the init shader, like we have our shader compiler, and so all we have to do is call that function. We're going to just use the shaders basic color .vs shaders basic color.fs. This should look pretty familiar to you guys. And then we're going to use that program. Notice there's like no error handling here. Like if this crashes, like the whole thing's going to go up in smoke. So keep in mind that in production software, generally speaking, you're like checking every line of code, which is why in the first lecture in coding, I was doing a lot of EHM stuff, and that's where that stuff really comes in handy. Cool. So we've gotten pretty far already. Let's pretend that we're doing the init triangle here. And so the triangle consists of 3 vertices. Right? So let's do vertex 1, which is the top point. And that's going to be vertices. We're going to push back GLM. In fact, you know what? I don't want to do it this way. I want to do it a little bit of a different way. So we're not going to go and create a whole new class for vertices, but let's call it struct vertex. And here we're going to use GLM vertex 3 position, and we're going to use GLM vertex 3 color. Nice. That's really it. And now instead of a bunch of these, we can now instead put this in here. Great. So the first vertex, vertex top point, is going to be equal to GLM. Let's be really explicit, because why not? Vertex top point the position is going to be equal to GLM vertex 3 negative 1 0f negative 1, or no, it's 1. It's 0. That's 1 0. This is our, remember, in 2D, we're still in 2D. And then vertex top point dot color is going to be red. Okay, and then we're going to push back vertex top point. Cool. Now we just need to do this a couple more times. Two, and this is going to be the left bottom. This is going to be the right bottom, right? And so the only difference here is we're going to make this one, this is RGB, so we'll make this one the G. We'll make this one the B. And bottom, so they're all going to be negative at this point, right? Yes. Okay, sorry about that. Got a little bit distracted. Let's just confirm, because I'm getting a little bit confused for some reason. Let's just copy this. Always good to be sure. Then that will put there. I don't want to get into issues with vertex winding, which is an issue that you will run into sometimes when a primitive like a triangle is not correctly wound. You can do counterclockwise or clockwise, and I don't know what the underlying implementation uses, so I'm going to go with something I know will work. So just to kind of confirm here, we've got the correct, what looks like the correct stuff going on. negative, negative, not negative, negative, and then negative, negative. Alright, let's try it, whatever. Worst case, it doesn't work. So next, we will want to set up the buffer data. So buffer data, GL array buffer. And now this is important. We are going to take the number of vertices and multiply it by the size of vertex. Now you've seen this in different ways, right? Where you had individual things. So technically we are passing a total of 6 vector 3s, but in the container of a vertex, and the vertex contains 2 of them as defined here. And so this is a little bit of a more eloquent way to do it, where we've put it into a particular format, and now we can just pass in the vertices, memory location, and the fact that we're passing it as a static draw. Cool. And that's already almost everything that we need. Let's count the attributes. Attribute count equals 2. And then we enable the attribute 0 and GL vertex attrib pointer 0, 3, GL float, attribute count times size of. Well, that's actually funny. We don't actually need to do that. We need to do, again, size of vertex. So this becomes a little bit more eloquent. And then we're still at GL void 0. Cool. And you'll see kind of the eloquence of this structure in a second. Am I missing something? Right, we don't have to normalize this. Yeah. And then this is the other bit. So this stays the same almost. So right, where it's the first attribute. We're in the float. We're still the size of. But now, all you have to do is the 1 times the size of GLM vector 3, as we had done previously. Yeah, pretty nice. Missing one. And then finally, we unbind the vertex array, although I kind of would prefer to put that here, honestly, because we kicked it off here, we bound the vertex array here, and now we're unbinding it, kind of, so that it can be used in different places. And that's really it for the initialization of the triangle. You'll notice that the size doesn't really mean anything here. But let's keep it there for now. So what would set scale do? Well, this is just a fun little thing, right? 1.0f. And all we would have to do is that. Cool. And you'll see how that plugs in relatively soon. And for the time being, let's make this just a little bit smaller so that we can actually see what is going on. What is going on? Can anyone tell me? I don't know yet. Finally, we fill out the draw method, which is we bind the vertex array, the RVAO. So you can kind of see how you can switch between VAOs, right? And then you would, again, unbind it down here. And then you just call the draw, which is GL draw arrays, GL triangles. We're telling it what kind of primitive. Where the first one is going to be at 0, and then the number of vertices is just going to be the size. That's really it, which is pretty nice. And that's all that it takes, except there's one missing bit. So if you take a look here, if I make a my new mesh, let's compile this code, make sure that we didn't break anything. Okay, what did we break? Vertex, right. We need to rename. That actually got a really big issue, left bottom. Vertex, right bottom. Great, okay. That was a big error, and it works. Now if you notice, if I run this and I hit this point, okay, cool, I have a new triangle, but notice that all of these things are still 0, and I can set the scale, but if I go and I actually try to hit draw, let's do that. If I hit draw, nothing will show up on the screen. There's a reason. The reason being that we haven't actually hit this code. Now there's one way to do it. My triangle new mesh, and then I can do mp triangle dot init, right? And that should hopefully give us what we need. But there's a slightly more eloquent way to do this. And this requires kind of an understanding of a very cool design pattern called factory methods. What we do here, instead of my triangle, a triangle equal to a new triangle, what we can do is we can go my mesh, make triangle. And in fact, we can even pass to it this scalar value and remove all of that. And how would this work? So we go in here, and we would create a new public static my mesh make triangle float size. Cool. And then we're going to go into the my mesh implementation. And this is something I wish somebody taught me a long time ago. Like, well, while I was in college. I did not learn a bit in college, so I figured you guys might like it. So my mesh p mesh equals null pointer return p mesh. And then what you can do is you can call init. You create a new mesh, p mesh equals new my mesh. And then you call pmesh dash init. And that will call all this stuff. But notice I'm going to change some stuff a little bit here. I'm going to go down, I'm going to put in a triangle specifically here. And that does require me to bind the vertex array in the opening and the closing here. Otherwise, it won't know what to do. And now I've got a slightly, and you notice I have this 0.5, and I can also then, after it's initialized, I can also go key mesh, set scale to the size, and if everything goes well, it should look exactly the same. Very cool. Great. So what else can I do with this architecture? I can also call it make a quad. And how would make a quad be different? So I would pretty much copy this. And instead of init triangle, I would go init quad. But we don't have an init quad. Oops. So how do we do that? We set this up, and then set up init quad. And most of this function is the same as the init triangle function, except we're going to create two triangles, which have, you know, in some cases are going to be very similar. We're only going to have, we only need 4 vertices though. So we have 4 vertices. This one's going to be the top left. Let's call it, we'll change this to just size. This is going to be top right. This is going to be bottom left. And this is going to be bottom right. And so the top left is going to be left and left. So the size is up there. It's up and to the left. The top right is going to have a positive size and a positive x, right? The bottom is going to have negative y, and left is going to be negative size. And then the bottom right is going to have negative y and positive x. Cool. Now notice I'm going to kind of divert this really quickly because I want to put these triangles together one by one, as you'll see why. I'm only going to put in the first 3 vertices of this for the time being. And now if I go here, let me get rid of this for now. Great. Quad. You can see with the same object structure, I can still basically do the same stuff. This is just a fun convenience thing, so I don't have to rewrite the code all the time. So if I run this, only the quad will get rendered in theory. What's the error? Right bottom is getting redefined. Right, so we have to go vertex bottom right. And in fact, we should probably rename all of them. So this is the vertex top left. This is vertex top right. And this is vertex bottom left. And actually slightly more eloquent than what I did down here. Let's do this. Just not push that last vertex. Okay, so we're not seeing anything, which is okay. Let's do this really quickly. And this should work fine, actually. We're not going to see anything, but now notice if I mess around with the ordering of these, we might see something. Now, why is that? So what just happened? Why is it that the top left and the top right, the ordering matters? And again, this comes down to what I was saying before. It's the winding. It's the winding of the triangle. So let me uncomment this. So what's happening here, you've got the top right, and then the top left, and then the bottom left. That's working. Right, if I run this, you'll see this thing. So you can kind of see it's going top right, top left, bottom left. In my perspective, that's counterclockwise. I know from the mirror it's going to be clockwise, but it's counterclockwise. And that's the winding order. If I do top left or top right, bottom left, what's happening is the winding order is meaning that the triangle is facing the other way. It's like this way, the top left, top right, bottom right. It's creating a clockwise. You can change the winding order of OpenGL, but generally speaking, counterclockwise I think is pretty standard, and it's good to stick to the standard. Now we've got one triangle. Now I want to create the other side of the quad being a square. And so I want it has to be counterclockwise, remember. So it's got to be top right, bottom right, and then bottom left. We don't need this line. And now let's see if we get the other triangle below. No, we do not. So what's wrong? So we have the top right, we have the bottom right, which is negative and to the right, and then we have the bottom left. Well, let's see. Let's try just different options. There we go. So what's happening here is we have the bottom right, the top right, and the bottom left. So again, we're doing clockwise. So why wasn't it working before? We had the top right, the bottom right, and the bottom left. Also, oh, that was clockwise. So again, I tricked myself. Cool. Now, all we have to do is uncomment these. Now we've pushed back triangles, this triangle and the bottom triangle. And what we'll see two triangles stacked on top of each other. And now we've got a nice little quad. Pretty easy. So yeah, this is really how you can do this stuff. It's pretty straightforward. And what's nice now is you can have just this mesh, make quad or make triangle, and so on, which is pretty cool. Let's really quickly fill out the destructor. Just to be clean, we want to delete the shader, and we want to delete the buffer. That's the geometry buffer, and then we want to make sure that, we're bound to nothing, and then we want to delete the vertex. Then we want to delete our VA. And that's really most of what you need for a mesh to work, really. But let me ask you a question, and then let me just really quickly try this. So now we've got this quad, but you'll notice when I try to move or I try to rotate, these are all functions that the underlying framework has provided us with. You can see that we're using the basic color.vs, and if we take a quick look at basic color.vs, right, whoops, you can kind of see it's just taking the position. This is an older one actually, this is not the same one we're using, we're not using the transform. What we want is we want to have the basic color, the basic.vs, right? Basic.vs is going to actually use this MVP, right? And if we take a quick look at the controls of this underlying framework, class controls, we can see that the whenever I move forward or I do something, it's going to move me around because we want to take advantage of that functionality because we can see that in the app class, when I display, I'm going to, I'm going to actually pull that, like where do I actually set those values? Well, let's see what happens if I use the basic. Will that actually get used? Doesn't look like it. I don't see my object anywhere. And why may that be? Well, another issue is we're not setting that MVP transformation. So we do want to start to add those things. That I think we'll cover in the next lecture of this, and that's where we'll kind of lead it off from there next week. Then we'll start to be able to manipulate the mesh and kind of complete this into a way where I can walk around it, I can move, I can use the camera system, and so on. Cool. All right, so let me undo that silly move. And now you can see we've got a quad and a triangle. In fact, we could create one of each, but you won't see them. They'll be on top of each other, but we can do it. We can do it anyways, just because we're cool. But yeah, that's not super helpful, but whatever. Although, actually, what I could do is I can make the triangle bigger, and then you can see it as well. Great. So yeah, now you kind of see pretty much like how what we have is already a pretty decent framework to get to a majority of the functionality that you need for a game engine. But a game engine will do a lot more than just draw a triangle to the screen. It'll do a whole lot of stuff. As you can see, these things, there's a lot of code involved to making a lot of this stuff work and function smoothly. So yeah, this week also you've got the C3 assignment, and the first I think one of the projects is coming up. We have an assignment this week for 3D primitives. So you'll be doing a lot of the stuff that I'm doing in these lectures. And you also have the exercise, the OpenGL shader exercise. So if you have any questions about either of those and what's up, please come to office hours. They're going to be tomorrow. Definitely excited to talk to you guys, and hope you guys are enjoying the class so far. Definitely eager to hear feedback, thoughts, or any other things you'd like me to talk more or less about. Okay, see you next week.